Welcome to True Projects. In this video, we are going to explain about the project that is Predictive Modeling for Fetal Health, a comparative study of PCA, LDA, and KPCA for dimensionality reduction. So, before getting into the execution, first let us understand what is the project about. Generally, pregnancy complications they can severely affect the health of both the mother and also the fetus, which makes early detection essential. So, during this pregnancy, expectant mothers and also the healthcare providers, they constantly monitor the well-being of the fetus to prevent complications that could threaten both the maternal and also the fetal health. So, one of the most common methods for this monitoring is called cardiotography, that is CTG, which records the fetal heart rate and also the uterine contractions. While this CTG provides a detailed view of fetal activity, and it is highly sensitive in detecting distress. Interpreting the results accurately can be challenging. Its low specificity sometimes causes misinterpretation, which leads to unnecessary interventions such as cesarean sections or failing to identify critical conditions like neurological damage causing by oxygen deprivation. Furthermore, manually analyzing these CTG readings is time consuming and prone to human error, creating a pressing need for more efficient, reliable, and automated methods that can support timely and accurate clinical decision making. Although automated methods exist for analyzing CTG, that is cardiotography data, they can often do make full use of dimensionality reduction techniques. They do not make full use of dimensionality reduction techniques, which are valuable for simplifying complex data sets while retaining the most important information. The main challenge is to reduce the number of features effectively without losing critical details that are the important details from the data, as this directly impacts the accuracy and also the interpretability of the fetal health predictions. So, by addressing this challenge, healthcare providers can achieve more precise diagnostics and they can also avoid interventions and make faster, better informed decisions during pregnancy management. So, this project is designed to enhance fetal health prediction by integrating advanced data analysis techniques with the machine learning models. So, here we will be employing multiple dimensionality reduction techniques that are PCA, LDA, and KPCA. PCA is principal component analysis, and LDA is linear discriminant analysis. And coming to KPCA, it is kernel principal component analysis. So these are used to extract the most relevant features from the cardiotography, that is CTG data. And this ensures that the essential information regarding fetal heart rate and uterine contractions is preserved while simplifying the dataset for more efficient processing. And here, after feature optimization, the reduced data is input into, that is, they are inputted into various machine learning models. And they are XGBoost, KNN, random forest, logistic regression, and support vector machine. So these models, the data is fed into these models to classify fetal health into normal, suspect, and pathological categories. So this approach improves classification accuracy and reliability, providing healthcare professionals with interpretable and robust assessments to support timely clinical decision making and better management of pregnancy complications. So by combining feature optimization with the robust classification, the system enhances the accuracy of the fetal health predictions and also it reduces the likelihood of misdiagnosis. So this approach supports timely and informed clinical decision making, enables healthcare providers to respond more effectively to potential complications. So this is what we have proposed in this project. And moving on to the extension part, as an extension, this project incorporates Smotin technique. It's a data balancing technique. So this is employed to effectively handle class imbalance, enhancing the reliability of the predictions. And also additionally, an ensemble model has been incorporated. That is a voting classifier model which combines K nearest neighbor, that is KNN, and also the XGBoost. So this model achieves higher accuracy, demonstrating the robust and precise performance. And to improve transparency and also the interpretability, explainable AI techniques have been incorporated, that is LIME and SHAP. So these are applied, which allows for the identification of most important features and which provides insights into the model's decision-making process. And also additionally, we have developed front end, which is developed using Flash framework. And this enables users to input the data and also receive predictions through a intuitive platform. And also user authentication mechanism is implemented in this project. So this mechanism, that is user authentication mechanism, it ensures the data privacy and also security. And this allows for practical testing while protecting the sensitive information of the user. So this is the extension part. Now moving on to the project implementation. So these are the steps followed for implementing this project. Now let us understand them step by step. So first, we have loaded necessary Python libraries for data processing, machine learning, visualization, and also for building the front-end interface. And in the next step, we have imported the dataset that contains cardiography, CTG records, and also the fetal health labels for the analysis. And in the next step, we examine the dataset to understand its structure, type of features, missing values, and also the basic statistics. Then comes pre-processing. So here in this step, we clean the dataset by handling missing values, correcting inconsistencies, and also preparing the dataset for modeling. And in the next step, we do visualization, where we have created sample outcome graph. So this visualizes the samples, that is the examples of the fetal health categories to understand the distribution of the labels. And then the correlation matrix. So this checks the correlation between features to identify patterns and the redundant information. And in the next step, we address the class imbalance by generating synthetic samples for minority classes and cleaning noisy samples to improve the model learning. Then comes scaling the data. So here we normalize the features values to a standard range, ensuring fair combination of each feature to model training. Then comes feature selection. So here we have used multiple techniques for the feature selection. So the first one is PCA, that is principal component analysis. It reduces dimensionality by transforming features into principal components while retaining the maximum variance. And coming to LDA, so this maximizes the class separability to improve the classification performance. And coming to KPCA, it captures non-linear relationships in the data for enhanced feature representation. Then comes train and test split. So here in this step, we divide the data into two subsets. One is training set and the other one is testing set. Training set is used to train the model and testing set is used to evaluate the model performance on the unseen data set. Then comes training and building the model. So here in this step, we train multiple machine learning models that may be XGBoost, KNN, etc. So here we will be using machine learning models for training the data. And then comes comparing the models. So here we evaluate and also compare the model performance using standard classification metrics, which are accuracy, precision, recall, and FN score. And those metrics, they are compared using graphs. That means we will be evaluating all the models using the graphs. And the best performing model, that is the model which achieves the highest performance, will be saved using joblib for the future prediction purpose. And in the next step, that is XAI used to explain feature dependency. So here in the step, we apply explainable AI techniques, that is LIME, SHAP, to understand the influence of the individual features on model predictions. And coming to the next step, here in this step, we have developed a user interface. So in that interface, users, they will be able to input the data and they can also able to securely log in. So here we have used Flash framework for development, and along with that, registration has also been set up for the login purpose. And SQLite database has been used in this project for storing the database. And here, users, they will be able to provide the information, that is the features in the front end for predicting the fetal health. And that information, it will be pre-processed at the backend and it will be fed with the saved machine learning model, which has achieved the highest performance. And that model will be giving us a prediction. So that model will be giving us a prediction, predicting the fetal health. So this is how we have implemented the project. And these are the algorithms used for predicting the fetal health. To implement this project, we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, let's open the code folder of the project. So these are the source code files in the code folder of a project, which are important for the implementation. So here in this, we have the data set that is used in this project. Let's open it. So here we have the data set. So these are the attributes, different attributes which are important for predicting the fetal health. So based on these attributes only, we will be predicting the fetal health. So these are all the dependent attributes. And this is the independent attribute, that is this variable we will be predicting in the front end. That is the fetal health. Let's close this. Get back. And here in this model folder, we have the algorithm information, which will be loaded into the project code during runtime of the application. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And this is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And in this folder, we have test cases, that is the sample file that we will be using in the front end for prediction. This is the notebook file, which is a Jupyter notebook file, and it contains a combination of code, graphs, and outputs all in one place. It allows users to write and also execute code in individual cells, which makes it a popular choice for the data science. And the same file is converted into PDF format, and this is the signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open Anaconda prompt. So here it is open. Now give the command cd and now paste the copied path. Paste it. Now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now we are supposed to compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port. So this is the local host and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it to any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here. Now click on enter. So here, this is the web page of this project. And this is developed using Flask framework. So now we need to sign up first. Click on sign up and enter all the sign up details if you are signing up newly. That is, if you have not created the account. So I have already created the account. So I will directly sign in. Click on sign in and provide your username and the password. Now click on sign in. Here we have signed up successfully and redirected to prediction page of the project. Now click on predict button. Here, let's click it again. So here you can see features, right? So these are the input features that we are supposed to give. Based on the given features only, we will be getting the prediction. So let's understand what are these features. The first one which we have is the histogram number of zeros. So this represents the number of zero values in the fetal heart rate histogram, indicating period of number of variability, which may reflect fetal inactivity or distress. The next one we have is histogram mean. It is the average value of the fetal heart rate distribution, which provides a baseline measure of the overall heart rate level. And then we have histogram tendency. This indicates the trend of that is the trend or the direction in the fetal heart rate histogram, which shows whether the heart rate is generally increasing, decreasing, or stable. Then we have fetal movement. So it measures the frequency or presence of fetal movements, which is an important indicator of fetal well-being. Then we have percentage of the time with abnormal long-term variability. This represents the proportion of the time during monitoring when the fetal heart rate shows unusual long-term fluctuations, potentially signaling stress or hypoxia. Then we have baseline value. It is the average heart rate over a long period, which provides an reference point to identify deviations or abnormalities. And the next one is abnormal short-term variability. It measures rapid short-term fluctuations in the fetal heart rate that are outside normal ranges, often reflecting acute fetal distress. Then we have accelerations. So it is a count of occurrences of sudden increase in the fetal heart rate, typically associated with the healthy fetal responses. Then the last feature that we're supposed to give as input is records sudden drop in the fetal heart rate, which may indicate potential hypoxia or the other serious fetal complications, that is severe declarations. So this is all about the features. Now let's enter the feature values. So open the test cases file, open the sample file. So these are the input features that we are supposed to give here. This column we will be predicting, that is the output variable, fetal health. Let's apply filter. So here we have total 3 classes. Let's check with the class 0. Click on OK. And now let's start entering them. So here the first one, let's try with the first case where the histogram number of zeros are 0 and the histogram mean is 125. Histogram tendency is 0. Fetal movement is also 0. Abnormality, we have it as 1 minute. So here we have fetal movement is 0 and then so here time with the abnormality value is 3. Baseline value is 125. And here abnormal short-term variability is 32. Accelerations are 0 and severe declarations are also 0. Now click on predict. So this given input, it will be pre-processed at the backend and then it will be fed to the trained machine learning model and that will be giving us a prediction. So here if you observe, we got the prediction that it is normal. That means the fetal health is predicted to be normal. No immediate concerns are detected. Let's check with the other case. So now let's check with this one. So here histogram number of zeros are 1. Histogram mean is 135 and histogram tendency is 1. Fetal movement is 0.008 and this one is 5. Baseline value we have it as 127. Short-term variability is 54. Accelerations are 0.005 and the severe decelerations are 0. Now click on predict. And here we got the prediction that the fetal is normal. Now let's check with the class 1. So click on try another prediction. And here let's check with this case where histogram number of zeros are 1 and the mean is 152. Tendency is 1. Fetal movement is 0. 44 is the time abnormal. And baseline value is 146. Short-term variability is 53. Accelerations are 0. And then severe declarations is also 0. Now click on predict. Click on predict again. So here you can observe that we got the prediction as suspect. So here it means that fetal health is suspect. So that fetal, I mean the parent, should consult the healthcare provider for the further evaluation. Let's check with one more. Now let's check with this case where histogram number of zeros are 0. Histogram mean is 146. Histogram tendency is 0 and fetal movement is 0.013 and this one is 38. Baseline is 146, 66, 0 and 0. Click on predict. And here also we got the prediction is suspect. So class 1 refers to the suspect where fetal is suspect. Now let's check with the last case, that is class 2. Apply filter to it. Click on OK. And now let's check with this case. So click on try prediction, try another prediction. So now histogram number of zeros are 2, mean is 76, histogram tendency is -1, fetal movement is 0, and this one is also 0. Baseline value is 121. Abnormal short-term variability is 70. Accelerations are 0 and severe declarations are 0.001. Now click on predict. So here you can observe that the fetal is pathological. That means immediate medical attention is recommended for this fetal. Now let's check with the last case. So now let's try with the first one, where histogram number of zeros are 0, 140, 0, 0.19, 019. And the next one is 82. Baseline is 140, 77, 0, and 0. Click on predict. So here you can observe that fetal is pathological. In this way, you can check the status of the fetal in the stomach. Now let's check with the graphs. So click on about. So here we have the graphs. The first graph which we have is the sample outcome graph. Here on x-axis, we have different classes, and on y-axis, we have count of the each class. Let's close this. And here, this is the sample outcome, but in the pie chart. So here you can observe 77% of the outcome is normal, and 8.3 fetus is of pathological, and 13.9 is of suspect. Here we have the same one, but with the class labels 0, 1, 2, 3, balanced outcomes. Here, if you observe, there is class imbalance, which means all the classes are not equal. The one class is very high, second class is, green color class is very low, and the third one is very low. So after applying the balancing techniques, here we have that is the class balancing techniques. Here we have all the classes to be in the equal range. Let's close this. And here, pie chart after doing the class balance. And this is the confusion matrix. This is the correlation heat map. So this shows the correlation between individual variables. And here, this is the confusion matrix. So here on x-axis, we have predicted label, and on y-axis, we have true label. And here, this is the principal component analysis, explain variance ratio. So this is the graph of the PCA. And this is the accuracy score. So this is the evaluation metric graph. Here on x-axis, we have all the algorithms that are trained, and on y-axis, we have performance, that is the accuracy of the each model. Let's close this. Accordingly, we have precision, FN score, and recall score. So now click on log out. In this way, just by giving input to the application, it will be predicting the health of the fetus. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.